So now looking at this example, you're probably thinking, wow, this is really simple looking, but I still don't know how to do it. Because it's just like, oh, how do I handle just an x? There's nothing in front of the x. There's no power. How do I do this? Very reasonable questions for sure. But there's a couple things that are implicitly happening with this function. For one, x is the same thing as 1 times x, is it not? 1 times anything is just that anything, right? And similarly, x is the same thing as x to the first power. We only have one of those x's. So if we have this form, we can definitely use the power rule just as we did before. So what we do is we take our exponent, we bring it down in front, multiply it by that 1. And then you subtract 1 from the exponent. So what this gives you is 1 times x to the 0th. Okay, what is x to the 0th? Hopefully you said 1, because it is. So you have 1 times 1 times 1. What's that equal to? 1. Okay, so that is the technical way of doing this. Another way of thinking about this problem is thinking, okay, if I start with just the function f of x is equal to x, what type of function is that? It's a line. It's a line of slope 1 starting at the origin. That is the center of your x and y graph. So the slope is equal to 1, and the derivative is the slope. So you can just think, oh, graphically, this is equal to 1, because that's the slope of that line. So saves yourself some work there if you don't want to use the power rule directly. Yes, you can use geometry for a lot of these problems if you understand what you're doing. So the kind of the key takeaway with this is that if you just see an x floating by itself, or like you see a plus x or a minus x, the x just kind of goes away, leaving you with whatever's in front. And in this case, if you just have an x, it's just 1. Okay, because technically there's always that 1 that sits in front of this thing. Or rather, here. This one. Okay, that 1 is always there. So the x derives away, leaving you with just that 1. So keep that in mind when you go through these problems. This is kind of a weird special case, but technically speaking, it's really not, kind of as we demonstrated here.